Hi, my name is Jungyu Jin. I'm an undergraduate at Kyungpook National University in South Korea. Today, I'll be presenting our work, Object Ratio Preserving Video Retargeting Framework based on segmentation and inpainting. This is joint work with Jaehyun Bae, Han-gyul Baek, and Sang-hyo Park. Let's get started. The contents are as follows. If the old ratio video, such as 4:3, is played on a wider screen ratio display, such as 16:9, the main content of the video is damaged and the context of the video is not maintained. We conducted a study that allows natural videos to be reproduced while maintaining the original context of the videos. Video retargeting is about changing the size of the video. Video contents are increasingly need to be played according to the characteristics of each display, including various resolutions or screen ratios. When the video has 4:3 ratio and played on the 16:9 display, the video contents may have a black box on both sides, or the contents would be overstretched by forcing the video to fit to the display. These methods may degrade the viewer's experience. To improve this problem, retargeting is needed to increase the width of the video. There are two important things for natural video retargeting. One is to maintain the spatial-temporal consistency, and the other is to minimize loss of information in the original video. We propose a video retargeting framework that maintains quality and spatial-temporal consistency via segmentation and video inpainting. There are several related works. In this study, using object detection network as a preprocessor, detect region of interest and retarget non-region of interest. This method highly depends to the location of region of interest. In another study, using recurrent neural network, use cropping and resizing. These operations cause loss of the original video information. These methods have advantage of preserving the context of the video because they maintain the original ratio of the object of interest. As in our study, there were studies using segmentation and inpainting, but these studies were image-based method. Thus, we try to apply segmentation and inpainting in video domain. Our framework can be divided into three stages in the order of segmentation, inpainting, and retargeting. First, the old ratio frames are fed to instance segmentation network to detect important objects. The segmentation network performs classification for each pixel. After detecting the important objects, detach the objects from the frame and make a binary mask for inpainting stage. In the study, our important object is a person, but a person of significantly small size is not segmented. Moreover, we added subclass objects that can be carried by a person, such as backpack and guitar. Stage is about inpainting. The inputs of inpainting network are the original frames and binary mask frames generated by first stage. The inpainting network fills the missing area in the frame. The output of this stage is the inpainted background of the input frames. Last, resize the width of the inpainted background according to the target ratio. We used bicubic interpolation for resize. After resizing the background, relocate detached objects on it. Since the background is stretched, but the size of the objects retained its original size. Thus, When relocating the objects, it is necessary to find the optimal location to create a smooth and natural context. The object relocating algorithm is explained in algorithm 1. This can hide the inpainted blurred location with the important objects. The dataset using this study is a video clip with no more than 3 human objects in the Davis 2017 Trainbell dataset. This dataset is a collection of video clips of 854 by 480, which have a 16:9 widescreen ratio. But we preprocess this dataset as a 4:3 old screen ratio by cropping the center of frames to size of 640 by 480 resolution. In the segmentation stage, we use the mask to form a model, which is the state-of-the-art model in instance segmentation task. And in the inpainting stage, we use the E2F model, which is the state-of-the-art model in video inpainting task. In our experiment, we compare between horizontally stretching method, seam carving, and our framework. This figure shows the retargeted research from 4:3 to 16:9. In the figure of a woman approaching the bench, in interpolation and seam carving, the person is stretched horizontally and loses the original ratio information. On the other hand, our framework generates natural research while maintaining the proportion of the person. You can also see this difference in the figure named parkour. Our main contribution is retargeting for entire videos, not single frame. Our framework produces natural video by maintaining spatio-temporal consistency without losing the original proportion information of important objects. In this section, I will talk about ablation study. Our framework uses segmentation and inpainting network. The quality of the generated mask by the segmentation network is related to the inpainting performance. Because most of the inpainting methods use the information of neighboring local context, the missing pixels can significantly degrade the inpainting performance. The table shows the performance of segmentation network evaluated by intersection of a union that predicted the person from the clips on the Davis dataset what we have used. Although it has a high value, it is hard to say that it has been precisely predicted. We can see the difference between ground truth and the prediction of the network in the figure. Thus, to prevent the photo missing pixel in segmentation network, we give an extra margin to the mask that can increase the performance of the inpainting network. We compare the performance of inpainting, which method can generate more real and smooth research that fits to our framework. To solve the inpainting problem with a single image-based method, we applied the work named AOT-GAN and two video-based methods, DFCNet and HFGBI. The figure shows the inpainting research of the image-based method and video-based method. In figure A, it is hard to find the front of the truck and tire. And in figure B, objects seems not removed and the wheel of truck was seen as 2. But in figure C, it almost perfectly estimates the area which was hidden by the person. Therefore, we can confirm that using HFGBI would be best to our framework to generate natural research. We tried several methods to determine the proper location when relocate the object to the retargeted background. In the original coordinates, place it in the coordinates of the original image. Because background is retargeted, the object is skewed to the left. The offset coordinate moves pixels by an increased width, so that the object is skewed to the right. Therefore, we place it in a natural position by giving an appropriate offset according to the position of the object, as in the algorithm on the right. In this study, we can show that the research on converting the screen ratio while maintaining the original ratio of the object still insufficient. We propose a novel unified framework that can retarget the older screen ratio to the wider target aspect ratio horizontally while preserving the quality of the objects. To improve our framework, research on how to relocate the detached object is needed. Thank you for listening. We write down contact information, so if you have any questions, you can get in touch with us. Additionally, we release the code on GitHub. Thank you.